Hi and welcome everybody. So my name is Olga Khan and I am the outgoing chair of the Competitive Strategy IG, and it's my pleasure to host this last webinar before I go. Welcome Hia Lee from London Business School, Leo Pangelupe from Wharton, and Angie Fairchild from Indiana to talk to us about competitive strategy and climate change. So you probably have seen that companies do compete on all of these net zero commitments. At least we see a lot of that going on in the press. Some of them are already walking back because they realize how hard it is to actually achieve these goals. But there is a lot of talk, maybe not so much walk. And a lot of us are starting to think about how to do research in this area, where to start, what data exists, how can we use it to apply to firms. And so when I was thinking about this webinar, I thought it would be great to put a panel of junior scholars that are dealing with these questions hands-on, that will share, any tips, any bits of advice that they, suffered through so that we don't have to when we start research in this area. And so I assembled this great panel, and we will start in the same order as I just mentioned. And I asked them to particularly focus on how to do research in this area. And mind that they are junior scholars, this is early work. And nonetheless, I think it's very important work, the strategy field, as well as competitive strategy interest group in particular. I also wanted to very briefly mention, if you go into SMS, we actually have an extension in Istanbul hosted by Sabancı University in the Sabancı Museum, as you can see here on pictures, that will also discuss some of these topics. And please, just scan the QR code if you have any questions or want to register for it, because I think the deadline is next week. So I thought I will just briefly mention this. It will end with a tour of the museum with cocktails. So with that, I don't have anything else to add. Let's jump straight to it. Sia, please upload your slides, and 15 minutes for every presentation. Please use the chat for questions, any clarification questions or any questions that you might have. We will get to them at the end, and hopefully we'll have time for a Q&A where we can also call on some of you in person. Thank you, and I can see your slides. So please, I will be the timekeeper from now on.
Thank you very much, Olga. Thank you for the opportunity to discuss about my recent research study, physical climate change exposure and firms' adaptation strategy. So some background of the study. In recent years, companies across the board are facing increasing physical climate risks. Climate-related extreme weather events, such as wildfire and floods, damage firms' property and disrupt their operations, for instance. Increased rainfall and flooding in Asia and the Middle East have impacted manufacturers, such as Toyota. Climate change does not only affect extreme weather events, it also brings gradual impacts on firms, such as water stress and rising temperature, which affect firms' resource availability and reduce labor productivity. For example, the rising temperature has increased the cost of cooling in energy-hungry data centers for companies such as Google. Facing climate risks, firms can seek to mitigate climate change or adapt to climate change, or both. Climate change mitigation addresses companies' impact on climate change and focus on greenhouse gas emission reduction. Examples include shifting to renewable energy and increasing energy efficiency. Climate change adaptation, in contrast, address the consequences of climate change on firms. For instance, some champagne companies in France have invested in English vineyard as the Champagne region has warmed. Management literature has primarily focused on firms' climate change mitigation strategy. Essentially, it is the decrease of firms' impact on the environment. Studies on firms' climate change adaptation, essentially strategies firms take to address the impact of the environment on the firms, are less understood. And this is exactly the focus of this study. So in practice, some firms adapt to the change. For instance, some champagne companies that I just talked about in France are investing in English vineyard as the climate in Champagne area has warmed. Starbucks develops coffee plants and coffee growing practices to make crops more resistant to new pests and diseases that spread with warmer temperature. However, there are also companies not adapting, even facing high climate exposures. For example, although Miami is known for its high risk of sea level rise, investors keep investing in properties there, and developers keep building with few climate change adaptation measures. So it is not clear to which extent firms adapt and under which conditions firms adapt to climate change. And it's important to find out. So in my study, I asked the following research question. How do firms adapt to physical climate change exposures? I developed a novel data set to measure firms' adaptation to climate exposure as a climate exposure year level. I find that most firms don't adapt to most climate exposures. In fact, only 23% of firms in the sample report any adaptations to physical climate risk exposure. And regarding how and under which conditions, I find that firms are, number one, more likely to adapt, and number two, with broader ranges of adaptation in response to the climate exposures that are most salient to their business. And turning to the mechanisms, I find that higher level of climate risks increase firms' perceived impact of climate change. Also, firms with better ESG capabilities and longer time horizons respond more often and more completely when facing higher physical climate exposures. So I will very briefly discuss a conceptual framework. One key characteristic of physical climate exposure is that it is long-term and beyond the time horizon of most managers and business cycles. And because physical climate risk is long-term and uncertain, the upside of adaptation, such as reduced damage and interruption, increased operational efficiency, innovation opportunities, are usually materialized in the long run, while the downside of it, particularly costly adaptation measures, tend to occur in the short run. As a lot of managers have a preference for the present and tend to favor less investment in the short run at the expense of long-term benefits, they tend not to adapt. However, firms' willingness to adapt can change if their perceived impact of climate change is altered. Unlike past climate or weather threats that may provide ambiguous signals about future impacts on firms, higher forecasted climate exposures indicate a clear and more significant risk to firms and increase firms' perceived impact of climate impact of change. And this in turn leads managers to reevaluate the ups and downsides of adaptation and more likely to induce them to adapt. As not all firms face high risks adapting, I also explore under which conditions firms would adapt more. Considering the uncertainties associated with climate change in the future, firms' ESG capabilities should play a significant role. Firms with better ESG performance are more likely to have organizational resources and capabilities that enable them not only to manage their environmental and social impacts well, but also to better adapt to external environmental changes. In addition, given the long-term nature of climate change, firms' time horizon, which is how far into the future firms consider risks when making decisions, should influence their perceived impact of climate change and adaptation strategies in response to higher climate exposures. Now I will spend more time talking about the data. So first, I collect firms' physical climate risk data from 427. It is a climate science-based data. 427 evaluates the climate risk by utilizing climate projection models at specific locations where risk factors are measured. It is not only about historical weather data, but forecasts the midterm climate impacts on firms. Also, climate risks of companies' direct operations are scored by aggregating different climate risks at each of their facilities. So it is a global data set, comprises over 2,000 public companies and over 1 million facilities across 200 jurisdictions and 10 industry groups. And I use firms' disclosed adaptation from CDP climate reports to approximate firms' climate change adaptation strategy. I read through all firms' disclosed adaptation strategies in CDP reports and hand-coded the data. First, I coded around 1,000 companies and generated a list of 23 categories of adaptation strategies. And here are some examples of these categories. And second, I used the list of categories to code all firms. So I code categories equal to 1 for a company that adapt in a specific category. So I iterate this process for all companies, and the final outputs have 23 scores for each company and each climate exposure in each year. I then merge the adaptation data with physical climate risk data at a firm, exposure, year level, and focus on climate risks of firms' direct operations. So I use adaptation dummy to measure whether a firm initiates a adaptation strategy or not, and adaptation breadth to capture the scope of firm's adaptation. Okay, now let me show some stylized facts about whether firms adapt to climate exposures. So this figure shows that most firms don't disclose to adapt to most of climate risk drivers. So the average adaptation rates across firms and climate exposures are only 23%. Also, for most climate exposures, firms adapt more through routine strategies than non-routine strategies. So routine strategies here means that enable firms to carry out routine activities such as risk management, buying insurance. And non-routine strategies are choices associated with firms' core assets and activities such as innovation, relocation, mergers and acquisition. So a plausible explanation for the difference between routine and non-routine adaptation is that routine ones are usually relatively quick to initiate and demand fewer resources compared to non-routine strategies. So this figure shows the evolution of adaptation strategies over time. Firms' adaptation increases over the years, particularly for non-routine ones. While only about 7% of firms disclose their adaptations through routine strategies, non-routine strategies back in 2011, the percentage increased to 13% in 2017. Then I tested whether firms are more likely to adapt when facing higher climate exposures. So model 1 here is a pooled cross-section model with country industry fixed effects. And I find that on average, firms facing higher climate exposures are more likely to adapt and with broader ranges of adaptation. And because the analysis is at the firm exposure level instead of firm level, I can add the firm fixed effects in model 2 and examine the results within firm between climate exposures. So by including firm fixed effects, it reduces the endogeneity concern that unobserved factors might make some firms more likely to adapt. So the result shows one standard deviation increase of climate exposure is associated with around 2.8 increase in adaptation likelihood and 6% standard deviation increase of adaptation breadth. So here I explore the mechanisms, perceived impact of climate change. So in the study, I collected firms' disclosed climate risk to approximate their perceived impact. I find that higher levels of climate exposures is associated with firms' perceived impact of climate change, and thus it's statistically significant. I then examine how firms' ESG capabilities interact with their adaptation. The results suggest that firms with better ESGs are more likely to adapt and with broader scope of adaptation when facing higher climate exposures. However, I do not find that ESG positively moderates the relationship between climate exposure and the perceived impact of climate change. One possible explanation of this null result might be that the sample in analysis consists of firms reporting climate change information through the CDP. And these companies are usually aware of climate change in general with a relatively high level of perceived impact of climate change when facing high degrees of exposure, and a higher level, like in terms of their ESG rating, may not further moderate this relationship. And similarly, I examined the moderating effect of firms' time horizons, and the results suggest that firms with longer time horizons are more likely to, number one, perceive higher climate exposures, and number two, adapt more when facing greater climate exposures. And to interpret the coefficient, the positive coefficient on the interaction term here suggests that a one standard deviation increase in the time horizon, which is equivalent to approximately 3 years, enhance the relationship between climate exposure and adaptation breadth in the baseline by 73%. Okay, to quickly conclude, this study examines how firms adapt to physical climate exposures. So I compiled climate science data with firms' disclosure on adaptation and examining adaptation strategies of public companies. So I document some stylized facts of physical climate risk and firms' adaptation by industry, risk, region, and also over time. So I find that firms facing higher climate risks are more likely to adapt, and with broader ranges of adaptation, firms with higher ESG and longer time horizons are more sensitive to higher climate risks. So I want to emphasize some of the practical relevance and implications of this study. Environmental policies have traditionally been focused on regulating companies' environmental impacts or externalities, such as pollution reduction. And in recent years, governments have been taking actions to mitigate the effects of climate change by introducing carbon pricing or setting targets to cut greenhouse gas emissions. Yet there are very few climate change adaptation policies. And this is probably because it was usually assumed that companies would have the necessary foresight and pursue adaptation strategies as an obvious preventative measure. The findings of the study, however, suggest that although companies are sensitive to different level of forecasted climate exposures, their adaptation are not always spontaneous, as they are influenced by other factors such as adaptive capabilities, firms' temporary preference. Thus, adaptation policies or incentives that encourage companies to address the impact of climate at least need to be considered. And for managers, the comprehensive measurement of different physical climate exposures and adaptation strategies discussed in the study can be informative to managers seeking to identify best practices or compare their own adaptation measures to those of their peers. So some thoughts on future research. Because climate change adaptation is still an emerging area of research, there are a lot of opportunities, and I think research opportunities, and they are in need. For instance, this study only focused on like big firms and also firms' direct operations. So future research may explore climate risks of different value chains, such as suppliers and customers, and see how firms respond to those exposures of different value chains. And also, like,
I think we out of time. Unfortunately, we have to go to
Okay.
the next speaker, but we can discuss this in the Q&A. So
Okay,
keep
sure.
that thought. Okay?
Thank you.
Thank you. Thank you. Leo, would you like to share your slides?
Yes, let me just, please let me know if you can see them.
They work. Thank
Great.
you. Go ahead.
Perfect. Thank you. Well, thank you, Olga. Thank you for the invitation. Thank you, Shah and Angie, for sharing the panel with me. Thank you for everyone that is attending. So I'm Leo Pongelupe, assistant professor at Wharton, and this is a joint project with an amazing team of collaborators. So Ilse Kivelenich from INSEAD, Sergio Lazzarini from INSPER, and Shini Wu from Columbia Business School. I just want to say that, you know, it's great that when you think about competitive strategy, not necessarily climate change is the immediate follower of it, but I'm really like delighted. It's really a pleasure to be in a session with these topics together, and I think and to see this movement in the strategy field on being more open to this phenomenon, right? Like climate change, social issues, and I think in great terms this reflects the benefit of having people like Olga, like Caroline Flamer, like Jiao, and many others that help us to expand our horizons, right? So, but jumping on the paper, so this is a project that started very small. We were specifically interested in understanding governance structures of desalination plants and the technology adoption that they have, and then does it start becoming like growing as a monster. You're going to see some of it here on the data. This is kind of like more or less a follow-up study that we are planning to do, so comments and feedbacks are more than welcome. So I don't need to tell you, I think Xia already mentioned several occurrences or climate-related events that are happening in the world, but one of the main ones that we are facing already is a water stress, right? So access to reliable fresh water for consumption or for agricultural use, right? So currently, we have 1/3 of the world population facing some level of water distress or not being able to access fresh water directly. And if we project population growth and consumption for the future in 2050, we're going to have 55% increase in the demand for fresh water. But as we can see, like we're going to have a good amount of countries, or especially some regions, that will be under severe water stress. So this is a problem already, and the tendency that we see moving forward is to increase. Interestingly enough, for this particular problem, we have technology that might help us, right? So there's always this tension of like how much technology can do for us. At least with fresh water we have. There is like, since the 1950s, desalination is a process that has been mapped and has been improved. We have these two main technologies. One that's called thermal or evaporation, basically traces back to the ancient civilizations such as the Egyptians. You heat up the salty water, right? We have plenty of salty water in the world, 97.5% is salty water. You heat up the salty water and you distill it and you collect the vapor, and you have fresh water. And you have the reverse osmosis, that you pressure the water against a semi-permeable membrane. You collect the fresh water on one side, and you are left with a salty solution on the other side. So technology can help us. The problem that we are investigating here is that despite technology being able to provide us fresh water and with low cost, there is a byproduct on this process that is precisely this concentrated salty solution called brine, right? And what we are interested in here is to understand what actually is happening with this brine, or in other words, what is the effect of the expansion of the desalination industry in the world in terms of the ocean ecological system, right? So aiming to understand the effect of desalination into the ocean waters or into maritime ecosystems, we collect this huge amount of data. First part of it comes from the International Desalination and Reuse Association. So this is really the population of all desalination plants in the world since the inception of the industry in 1950 to 2015. So we have information on all the plants, all desalination plants in the world, their geolocation, their governance structure, capacity, and so on. So the technology that they use, so on and so forth. We merged this data with satellite data collected by NASA Aquarius mission that since 1992 to 2015, actually to nowadays, but we use until 2015, collect daily data on the salinity level and the temperature level of each one of the oceanic grid points in the world. So this is amounts to almost 107,000 unique coordinates in the oceans. And we have information on the salinity level of those locations, the temperature of the water in those locations, and the variation that it has by depth. So I'm not a physician, astronomer, or anything, but physicist, sorry. I'm not a physician as well. But the way that it works, the radiation from the sun hits the seawater, bounces back, the satellite collects this information and can infer based on some parameters what is the salinity and temperature and the variation per depth. So what we do, first of all, it's important to know there are many desalination plants inland. Usually these are to desalinate on underground water or salt lakes. But what we are focusing here are the desalination plants that are on the coastal areas. So we mapped all the desalination plants in coastal areas, and we created a buffer zone. So how far actually can be the effects of this disposal of the brine that they process. And we want to see what is actually the average effect of those desalinations on the quality of the oceanic areas or the oceanic ecosystems. So just just descriptive statistics, no controls here, is raw data. The bars are the averages. The dots are the specific oceanic grid points, right? So they are scores for salinity and temperature. And we differentiate here oceanic areas that have no plants, buffer zones, so exactly those borders here, those margins, and the exact coordinate where the plant is located. So what we can see is that on average, where the plant is and the buffer zones have higher salinity and also higher temperature. But the problem is we need to control for location fixed effects, because it might be just the fact that a plant is located on a sea or an ocean that is naturally more salty, right? So the Mediterranean, for instance, is more salty than the Atlantic. The Atlantic is more salty than the Pacific naturally. So we need to refine our models, and that's what we do. We're going to analyze in 3 dimensions: the spatial dimension, temporal dimension, and the depth dimension. So the spatial effects of desalination plants, what we can see is that it increases significantly the salinity level and the temperature level of the oceanic areas in the exactly location, the latitude and longitude that they are located, right, in the oceans. And as you go far from that in the buffer zone, it is still significantly increased despite being lower in magnitude. So in other words, the brine dissolves itself in the water and spreads out spatially through long distances. Just to give you an idea, this buffer 1000 is almost 1,500 kilometers away from the exact point where the desalination plant is located. And these are regressions with location and time fixed effects. So we are comparing 2 locations that are similar enough but didn't have the implementation of the desalination plants. So we see spatially there is an increase in the salinity level of the waters and also the temperature of the oceanic water. If we analyze the temporal effects, so the before and after of the launch of those plants and what is the effect over time, this first set of graphs are quarterly, so you see the seasonality. These ones are smoothed because it's yearly averages, right? So we see that there are no pre-trends before the launch of a desalination plant, but once the plant is operating, there are these seasonal increases in the salinity level that trends up over time. Temperature is a bit more tricky precisely because of the seasonality of the year, so we have a lot of pre-trends. When we smooth it over year, we see that there are increases over time in the salinity, and it seems there are increases over time also in temperature, despite having a little bit of pre-trend. So we can see that the plants are increasing salinity spatially and arguably increasing salinity also temporally. Finally, we analyze what is the effect of this desalination plants across different depth levels in the ocean. So oceanographers and marine biologists define 3 areas in the ocean. The first area is called mixing zone, or is the surface area. This is the areas here in the top of the oceans. Then you have this changing zone, that is this light blue area. And then you have the deep zones in the oceans that are down there, right? And they have specific relationships with temperature. As you can imagine, temperatures are usually higher in the more surface areas and then goes down pretty much as you go further deep in the ocean. So what we see is that, again, controlling for fixed effect of location and time, the launch of desalination plants have a huge increase in the salinity levels of the surface areas and also temperature in the surface areas. And as you go down, it declines. So we know from research in marine biology and oceanography that it takes 10 to 100 years for the salt to dissolve and sink in the ocean. That's why we can see that actually the effect of these plants happen more on this mixing layer where the brine is disposed. We finalized doing some calculation. I'm not getting much detail here, but just if we consider the average effect that we have for those desalination plants and the number of desalination plants in the world, we can see that the effect that we had in increasing the salinity can be responsible or can be related to from 11.8 to 14% of the reduction in the sea ice covered in the polar area. So we can see direct effect of those anthropic actions in warming up the planet, reducing the sea ice cover and affecting or increasing, augmenting the climate change. Finally, since this is a strategic management group, right, I think it's important to bring it back home, right? What we are exploring also in this research agenda is that management has a lot to do with that. First of all, there's heterogeneous governance structures for those desalination plants. Some of them are public commissioned, some of them are private commissioned, and we see that they are very heterogeneous also depending on the institutional level of countries, right? Depending on where you are, you're going to have more prevalence of public or private. More importantly, when we consider the launch of these plants, the increase in salinity seems to be happening mostly in countries with lower level of development, where both public and private increase more the salinity level of this ocean. So again, we can have this heterogeneous effects depending on who is the client commissioning the plant, where this plant is located. And as we all know, climate change will affect much harsher populations in the global south. And for instance, in this case, these are the areas where we see increases in salinity even more significantly and in higher magnitudes. Right. So to conclude, I know that I'm reaching out my time limit here. The main takeaways that I would like to give you is that we can use the toolkits that we have in economics and management to understand more climate change, or in a big in a higher level using public available data. The desalination data is private, we bought it, but the NASA data is out there. So I incentivize people to look for this type of data. It's an important topic because we know that increasing salinity and temperature in the oceans reduce oxygen level in those marine ecosystems. It creates those dead zones. It creates bleaching of corals, and it has effects both in the location and also globally. So it's an important topic for us to consider. And most importantly for this audience, several of those problems are managerial and economics problems, right? So brine is not easily observable, so it might end up in a tragedy of the commons because we cannot necessarily measure. We can think about governance structures that will reduce the disposal of this byproduct in the ocean, better process it and extract the minerals that are out of it. We can think how to create a governance across countries that will help also countries in development and avoid reaching a point where climate change becomes unsustainable, both societal-wise, but also for the industries that we care deeply about. So with that, thank you for having me. Looking forward to the chat.
Thank you, Leo. You actually saved us a minute. Sounds great. Angie, can you share your slides? Yep.
All right. Well, thank you. I am really pleased to be here talking with all of you about climate change and competitive strategy. As Leo said, these are such important topics to combine because what we see is huge impacts of corporate organizations on the climate and a huge need for them to adapt in order to maintain the quality of life that we've come to expect. So absolutely two important topics that I like to see together. I'm going to take a bit of a different approach with this presentation. Rather than going through one specific paper, I want to talk a little bit about the CDP data, the portion of it that I've been using, in the hopes that if there are students or people just interested in researching these topics, you'll get an overview of what's in this data and how it might help you. And I will share briefly two approaches to analyzing this data that I've taken in my own dissertation research. So with that in mind, I want to talk about the Carbon Disclosure Project. So Xia already mentioned that she's used this data in her research that she presented. So what is it? It's an annual survey that has both voluntary disclosures and disclosures requested by supply chain partners, where companies, governments, other entities can report on not only their emissions that they generate, but also the goals that they've set and govern and think about climate change and climate change management. So it is self-reported data. It's also used as a input source for a lot of the ESG and financial ratings that you may be more familiar with. So if we're talking about Bloomberg, if we're talking about Asset4, if you read in the documentation for those data sets, many of them are drawing on the Carbon Disclosure Project data for the climate change related inputs, because it's one of the largest scale and really only available data sources for some of this information. It has more than 10,000 companies, and the data goes back at least to 2011 up to 2023. One of the pitfalls of working with this data, though, is that the survey has changed significantly over time. So there are some consistency issues as you see new data fields added sequentially, and data fields change to become better aligned with shifting sustainability standards and norms in the monitoring and measurement space. So I already talked a little bit about this, but in most of the working papers and conference presentations and published papers that I've seen on this, we're mostly interested in this firm year level data that talks about goal setting and governance and risk management, in addition to the raw numbers in terms of emissions volume and compliance actions. If you start diving into the data, though, there's a lot of richness there that I haven't really seen exploited in the research. So there are, for example, detailed modules for specific sectors like forest management, water management. There are some really interesting text pieces that, like, we saw Xia analyzing some of that work on adaptation measures, but there are also, like, firms self-report why they think certain scopes of emissions are or are not relevant to them, or why they included certain things. So there's a lot of this this manipulation of what they want to present to the world and sort of self-justification that I think has really interesting potential for insights for management scholars. The data that I work with primarily comes from a subsection where firms self-report the specific initiatives that they've undertaken to reduce their emissions in a given year. And I think this is so interesting because it explodes this firm year level data into initiative level data, where you get really fine-grained quantitative and qualitative information about what the firm actually did to reduce their emissions and the impacts that they expect to see from these actions. So on the right of the screen, we see just a snapshot from a couple of companies where we get their qualitative information, like what it is that they say they're doing, how do they position this, how do they talk about it, as well as the quant measures of the emissions that they've avoided or reduced, how much it cost them, and how much money they expect to save in the long run. And it's really this data that I'm working with. Oftentimes in management and in economics, we think about the marginal cost of emissions reduction, and we can compute that with this data. So just plotting the ratio of the cost per ton of emissions reduced, you get this really interesting outcome where the modal initiative has a total cost of emissions reduction that is very, very close to zero. And then the majority of initiatives have negative costs, meaning they save money in the long run. And it's really only a small portion that are reported to have net costs going forward. And some of that is related to the structure of the data, but some of it is just that the upfront costs exceed the ongoing cost savings. So I'm going to show you really two approaches that I've taken to dealing with this specific initiative level data. And there's so much in here that I'm sure there's more that could be done, but I'll focus on just these two. So the first one is a study in which we calculate the realized marginal abatement cost curves, and then a second study where we're really looking for a novel way to identify the trade-offs that organizations are making between the costs and the benefits and the more qualitative expressions and sort of stakeholder management aspects of these initiatives that they're reporting. So onto the marginal costs of abatement. The probably most commonly cited policy lever that we see in the news among policymakers, among economists for reducing emissions is to put a tax on carbon. And this really relies on the economic logic that firms should, when facing a cost to emissions, they should choose the least cost initiatives first and then progress their way up towards higher cost initiatives. And that logic really underlies the idea that a carbon price is going to get us to an emissions reduction target in the most economically efficient way, so with the least use of resources. But this hasn't really been tested, right? It's very theoretically strong, but it's hard to get data on whether firms are actually doing this in practice. And that's where the CDP data comes in. So we see, for example, consultancies will help firms organize their potential emissions reductions, and they'll put them into this marginal abatement cost curve type structure. So I've taken this one from Deloitte. It's an example of a dashboard tool that they're trying to sell to their clients. And the idea is you can see what's cheapest and what's most expensive, and that will give you an idea of the optimal sequence. What I find in the CDP data, though, is that doesn't really exist. Okay, so I took for each firm reporting multiple years in the CDP data and tried to give them an observed marginal abatement cost curve where we're looking across time, the size and scope of the initiatives that they undertook and their marginal cost. And what we can see is that these plots, at least the first two, look nothing like the stylized plot that we expect and that underlies the policy recommendations that we most often hear. The only one that does sort of look like the stylized plot that we want to see is this third one on the far right, where we do actually have a roughly upward sloping emissions abatement cost curve, but it's largely driven by a set of outliers that are very expensive but low emissions impact. So there's something going on here. And so the question that we had in this paper is, how can we, first of all, translate these into a set of actions and sequenced actions that would make sense according to our policy expectations, and then observe who is taking this expected type of action and under what conditions. So I'm not going to go into all the details, but suffice it to say that we've calculated the marginal abatement cost curve slope for these firms. And what we find is that, first of all, almost no one, only about 13% of firms actually have the upward sloping marginal abatement cost curve that we would expect. So this is the slopes of their abatement cost curves. And in the orange box would be the slopes that are both statistically significant and positive. So this is kind of what we want to see. And most firms don't fall into that category. What we find is that there are only weak correlates with signals that should push firms to be more efficient. So if they are setting science-based targets, this is loosely associated with a lower likelihood of having less efficient, or like the opposite of an efficient marginal cost curve, but that's really the only association. Then if we look for other patterns that might try to describe the sequence of actions that firms take, none of the more reasonable theoretically identified patterns really make sense with this data. So we're pursuing this abductively to try to figure out, what is going on here? What kind of sequence of actions makes sense and is actually observable in the data? So that's the first study. The second study, sort of given this finding of the first study that linear sequencing doesn't seem to describe what a lot of firms do, well, all right, if that's the case, then let's think about trade-offs. Let's think about the dynamic pros and cons of specific types of actions, and then figure out if we can draw anything from the choices that firms have actually made in practice. So to do this, basically, we're using this initiatives level data and breaking it into or decomposing each action into its component parts. So in this case, we have the volume of emissions, the financial aspects of the emissions reduction activity, both its upfront costs and ongoing cost savings. And then we've used text analysis to parse out the kinds of messaging and the content described in each initiative. And when we do this, we then put it into a choice model where we simulate a search process and then use a latent class logit to identify different archetypes of firms based on the trade-offs that they actually make. And since we're running out of time, I'm just going to skip over this part in terms of its content output, and just say that this idea of letting the data drive our understanding of trade-offs and trying to position these really granular actions in a space that simulates search and simulates a decision process that we might see in the real world. It's just a really different way of looking at the CDP data than what we've seen in other studies. And it's something that I hope we can sort of embrace as a way to study both heterogeneity in the marketplace and get into the granularity of action as opposed to like firm level proxies. So, yep, in the interest of time, we're going to skip all of this stuff and move on to just say that
You have 3 minutes.
Oh, I have 3. Oh, I have more time than I thought. Okay, we'll still wrap it up though. I just have 2 key points here that I want to make. The first is that when you look at the CDP data and any of these really interesting granular data sets that exist to measure climate and to measure what firms are doing, think outside the box. Think about what this can represent that gives you an angle on what managers are doing, but maybe not in a traditional way, all right? In these studies, we're looking at granular actions at large scale, but there are a lot of other data sets, other options that let you get at the same sort of question and lets us really dig deep into what firms are doing. This enables some unique empirical approaches, which can be risky. And it's also important to note that, like any data set, these have significant drawbacks. So with the CDP specifically, it is self-reported data. It is self-selected, and it also has a lot of noise, a lot of jockeying for position, a lot of room for ambiguity in statements made, which also gives us a window on what firms are thinking in their reporting decisions. The empirical conclusions from these studies are really, first on a policy level. My takeaway from the first study is that if a policy prescription seems too simple, it might be. There's more going on here than can be easily described in optimization patterns. And then second, that when we start thinking about latent groups and groupings and we get this granular data, we can think about theoretical challenges like decoupling as a spectrum that can be measured in terms of matches between different types of policies and practices that can be more or less tightly coupled. And that's where we're going with this research. So with that, I'm done. Please feel free to email me. I'm looking forward to all the comments and conversation in this session. And I'm really thankful to Olga for having put this together and glad to be here with all of you. So thank you.
Thank you. Thank you, Angie. Thank you for finishing on time. And we still have time for questions. So there's already a conversation going on in the chat with the other 2 papers. Are there any questions for this last presentation? I think I'm trying to understand if all the questions were already answered, right, Leo, for you and for you here?
I answered 1 and I'm typing the other 2. I can also talk if that's quicker.
Please, go ahead.
Okay, so I think I answered Anthony's question. So there's another question from Jingshu Luo asking about the coding, why it's 23 categories and not 5, 10, or 15. What I use is just the inductive approach. So all the codings are grounded from the data. I didn't have anything in mind I need to have 5 or 10. So those are just from the data. And of course, I refers to some of the previous categories, the names of adaptations such as buffer and those names. But because my research it's more of like cross-sectional, cross-country data set, so it's much bigger. As such, I probably have more adaptation categories compared to some of the previous papers who only focus, say, on ski or 1 sectors. So, and also after I did the coding myself, I also have at least 2 other people double checking with the categorizations and make sure we have like the similarity rates above 98%. So to confirm those categories. And I think there is another question. Let me see.
Instead of the questions, because I think they have been answered in the chat, let's take the last 5 minutes and go around the speakers again and talk about, just any sort of advice, any, words of wisdom, given the research that you've been doing. What sort of challenges have you faced, maybe whether it's in the review process or in the actual research process, that maybe our audience would like to know about? Any warnings, sort of, so to speak? Leah, let's start with you.
Yeah, sure. So I think I mean, I don't know words of wisdom, but like coming from me, but just like some comments from my personal experience, I think it touches back to a point that Jean raised on the chat, right? So like sometimes studying those topics because they are systemic topics or systemic problems, the traditional neoclassical approach or the traditional strategic management 101 approach is not like necessarily the best fit, right? So, and then we get pushback from referees and editors and peers because, oh, what are you doing actually? Doesn't make any sense. Why are you even considering studying these topics? We don't do this kind of stuff. And I think it's, I have a lot of hope because I see a movement, especially, I mean, there are so many people here, Leandro Nardi, Lucrezia Nava, Nara, Francisca that is here, France, so many people actually that are pushing the frontier of those topics and bringing it closer to management, because if you think about it, they are all about how you manage these externalities, how you manage incentive systems, governance structures, right, to internalize those problems and consider them fully, right? So I think we still have a high bar to cross because they demand more from us to convince that this matters for management. But at the same time, it's so rewarding to see the movement and this community being built and getting stronger day by day. So I would say, word of wisdom, I would say, don't lose faith. Keep going forward.
Thank you, Leah. Xia?
Well, similar to Leo, I think the fact we are having this webinar is kind of encouraging, which means like it is a very important topic for the management community. And I think it's for me, I think it will be great like to have more and more research which could integrate more of like data from nature, from science, those type of data, because today these problems is not only about like between firms, between like regulations. There are a lot of like more. It's also about like how do companies and the nature interact with each other. And I think there are a lot of opportunities for collecting new data, which probably already exist in other research fields, but we just try to think more on how to integrate them with management literature.
Thank you. Thank you, Hugh. Angie?
Yeah. Okay, I have one, I guess, a point of hope and then also a question that I want to add to this. This is a little bit echoing what Xia said, but I think one of the great things about working in this space is that there are so many unique data sets that we can tap into that let you answer these kinds of questions that just haven't been used in our literature because we're working with CompuStat, we're working with patents, we're looking at other types of outcomes, which means that, you can pull in the climate trace data, you can pull in this Moody's climate risk data and find new things that it's kind of like a blue ocean problem here where we have a lot of opportunity because there's mounting interest and many fields of science contributing in ways that we can then add our own managerial insights to. So I'm hopeful from that respect. My question though is around like what it all means, because one of the problems, which is not just in this field, but is in sort of management as a whole, is these are backwards looking studies. Like all of our studies that we've discussed today are looking at what's been done in the past, harms perpetuated previously, actions taken to protect a firm's individual interests. And I think that solving these problems requires a forward-looking approach, and it also requires a willingness to think about economics and the purpose of the firm differently, and that's a hard thing to do in a research article. And it's something that I just sort of bang my head against the wall thinking about, like, how do we make this better, more impactful, more meaningful in a real and applied sense? And I don't have the answer to that, but I hope that as a community we can be thinking about these things. As junior people, obviously, we're thinking about our tenure clocks and about trying to get our pipelines in order to be successful as scholars. But I think as a field, we need to be thinking about what it all means and the bigger picture. And I would love to talk to any of you about that. Find me at a conference. We'll chat for a while. It's my favorite soapbox.
Thank you, Angie. With 1 minute to go, I do agree. Forward-looking would be wonderful for practitioners because that's what they really want advice on. But I also think that our historical studies actually can give them certainty as to what will happen in the future, given the history, right, and given what we show with the patterns in the data. But with that, I think that gives a lot of food for thought for our audience, and thank you, authors, of course, for presenting your work and sharing these bits of advice. On this note, I think, thinking about the future, and as one of the audience members just put in the chat, we also don't have much time, right? Unfortunately. With that, I guess here's to more research. Here's to more research on these topics at this intersection using this data, or maybe even more. Thank you all. Thank you all for coming, and thank you for joining us today. And thank you to the presenters. And good luck, everybody. Bye.
Thank you.